All right, we are back with example 3. We are going to be proving triangles are congruent. Now, the last time we proved that triangles were congruent was in chapter 4, lesson 1, when we were talking about two triangles being congruent if we can show that they were reflections or translations or rotations, right? And if we could show that, then we knew that the triangles are congruent. This right here is the start to a new way of talking about triangles being congruent. And the way we're going to do that is by showing the definition of triangles. And that's basically if you can prove that all three sets of angles, corresponding angles, and all three sets of corresponding sides are congruent, then you know that the triangles are congruent. So that's really talking about 6 pieces of information. So we need to prove 6 pieces of information. We need to prove that there are 3 angles. I'm just going to say angle, 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 right? Corresponding angles. And then we need to show that there are 3 sets of corresponding sides that are congruent. So if we show that all 6 pieces of those triangles are congruent, therefore we know that the triangles have to be congruent by the definition of congruent triangles. All right, so let's just go ahead and get started. And there's a lot of given information here, and we're just going to break it down one step at a time. So the first part it says is angle YWX and angle YWZ are right angles. So YWX, so this one, and YWZ are both right angles. Okay, so that's what going to be one set of angles that are congruent. Then it says YW bisects angle XYZ. Ooh, that's interesting. YW bisects angle XYZ. Think about what that means. What does it mean when this segment bisects an angle? Do you remember? Yes, it means that this segment bisects means cut in half. If it cuts in half, that means that these 2 angles are congruent. Okay, so that's one set of congruent angles, and that's going to be 2 sets of congruent angles. What's the next part? W is the midpoint of XZ. So W is the midpoint of XZ. What does that mean? What does it mean if W is the midpoint of XZ? Well, that means that these 2 sides are congruent to each other. Okay, so now we have one set of congruent sides. And lastly, it tells us that XY is congruent to YZ. Okay, that is a lot of given information. What we have to do is we have to prove that triangle XYW is congruent to triangle ZYW. So we have to show that these 2 triangles are congruent. So to do that, we need 6 pieces of information. Did this given information, did it give us 6 pieces of information? I'm not sure. Let's go through it again, okay? So this first part, YWX and angle YWZ are right angles. So we're going to go ahead and write that down first. So angle YWX and angle YWZ are right angles. Okay, and that's just given. Now, at this point, we haven't stated that these 2 angles are congruent, so that's kind of the next step. It gives us this, and we have to state that they're congruent, and we have to have a reason. So, these are both right angles, so what that means is that they are congruent. Do you know why? They are congruent because of the right angle congruence theorem, which just states whenever you have, 2 right angles, they're congruent to each other. Right angles are congruent. Perfect. Okay, so we have one angle. So this right here, this information tells us that one angle is congruent. So we have one of the 6 pieces of information, right? This angle is congruent to that angle. Perfect. Okay, so that's 1, 5 more to go. Let's go to the next. It says WY bisects angle, I'm going to switch up the color, WY bisects angle XYZ. Okay, so bisects means it cuts it in half, right? Which means that these two angles are congruent to each other. But first, we have to just go ahead and write down that given information. So YW, we'll segment YW bisects angle XYZ, that is given. And we can state that X angle XYW is congruent to angle WYZ. Why? Because of the definition of a bisector, or angle bisector, right? So there's our second angle, right? So we have another angle right here. Another angle that's congruent. Okay, so there's our second angle that's congruent. Perfect. So we just need one more, right? Okay, let's see if it's found in the given information. So we did this piece, we did this piece, now it's time to do this piece. So it says that W is the midpoint of XC. So if W is the midpoint of XC, we know that these two are congruent to each other. Okay, but we have to write down this given information. W is the midpoint of XZ, line segment XC, that's given. And so because of that, we can say that XW is congruent, segment XW is congruent to segment WZY because of the definition of a midpoint. Perfect. Okay, so we have that piece. Ooh, this gives us a side, right? I'm going to use pink. So now we have one side. So we need 6 pieces. We have 2 angles, corresponding angles that are congruent in one side. We need 1, 2, 3 more. We need 3 more pieces to show that these 2 triangles are congruent. Okay, so let's keep going. What do we have? XY is congruent to YZ. So XY is congruent to YZ. So that's basically these two are congruent to each other. I think I'm going to use this color here. That's nice. It just flat out just tells us. So XY is congruent to YZ. And that's just given. And that's another side, right? So there's a side, there's a side. We got 2 angles and 2 sides. But there's no more given information. What are we going to do? Let's look at it here. What do we see? What do we see? What do we see? We need one more angle. Well, we know that these 2 angles are the same, and we know that those 2 angles are the same. We need these 2 angles to be the same. Do you know anything that we could say that would tell us that these 2 angles are the same? Angle X being congruent to angle C. Well, do you guys remember if you have 2 sets of corresponding angles, right? These are congruent and these are congruent. These have to be congruent because do you remember? Angle X is congruent to angle Z because of the third angles theorem. Do you guys remember that one? If you have this one is equal to this one and this one's equal to that one, then this one and this one have to be congruent to each other. Perfect. Okay, so, oh wait, what was that? What color? Yellow. Ooh, we have all of the angles. That's perfect. Perfect, perfect, perfect. Oh, we're just missing that one side. Well, which side is it? Let's look. Okay, we know that this side is congruent to that one. We know that this one is this one. The third side was right here. So we basically just need WY to be congruent to WY. What is that? What is WY being congruent to WY? Do you guys remember what that is? Line segment WY is congruent to line segment WY. That is the reflexive property of congruence. And there we have it. There are our 6 pieces of information. We have 3 sets of corresponding angles and 3 sets of corresponding sides. So boom shakalaka, we have it all. If we have all three angles are the same and all three sides are congruent, then we know that this triangle XYW is congruent to ZYW. So we can say that triangle XYW is congruent to triangle ZYW because of the magnificent definition of congruent triangles. Perfect, and we just want to make sure that we wrote this down. So X and Z, yes, they are congruent. Y and Z, Y and Y are congruent, and W are congruent. Perfect, so we wrote it down perfectly. Awesome. Okay, let's look at the next one. Check it out, example 3. So let's look at this problem. There's a lot of information here, right? A lot of given where you have this picture, and what you need to prove is that triangle ABC and triangle DEC are congruent to each other using that definition of congruent triangles. So remember, you need 6 pieces of information, 3 angles, and 3 sides. Wait. 1, 2, 3. 3 angles and 1, 2, 3 sides. 3 and 3 makes 6. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work that out. And when you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's go ahead and get started. We need 6 pieces, right, of information. 3 angles and 3 sides. Okay, let's do this. So what's the first bit it gives us? AD bisects BE. So line segment AD bisects BE. Well, if AD bisects BE, then we know that it cuts it in half, so these are congruent to each other. So I'm going to write that first. AD bisects BE. That's given. And we can say that BC, what about BC? BC is congruent, line segment BC is congruent to line segment CE. Why? What reason did you say? And you should say that because of definition of a bisector. Okay, that's why. Okay, perfect. Let's go to the next part. It says BE. Let me change my color. Oh, wait. What's that, a side? Okay. So we have a side being congruent. So BC is congruent to CE. Okay, so that's one side. So we have 1 out of the 6 pieces of information. All right, let's go on to the next bit. It says BE bisects AD. BE bisects AD, which means that these sides right here, AC and CD, are congruent. So let's go ahead and write this right here. BE, line segment BCE, bisects AD. That's given. And it's going to be very similar to this, which means that AC is congruent to CD because of definition of a bisector. Okay. Oh, there's another side. All right. Okay. So side. Okay, now 2 sides. Perfect. What's the next piece? It says AB is congruent to DE. So AB is congruent to DE. There's 1 hash mark. That's nice. AB is congruent. Line segment AB is congruent to DE. That's just given. Super easy. So those are our 3 sides that are congruent. Perfect. Now we just need those 3 angles, right? What's the next piece it tells us? Just angle A is congruent to angle D. Okay, I'm going to call this 5.5 just so there's not a space there. Okay, so angle A is congruent to angle D. Angle A is congruent to angle D. Okay, that's just given. All right, so we have 1 angle So we have all three sides and one angle. We need two angles left. And I always like to write this because this kind of keeps track of like where I'm at with the problem. So I need that 6 pieces of information. I know that I have my three sides. I know I have one angle. I need two more angles. So when I'm looking at this picture, I know where I need to like kind of focus my attention. So this just kind of helps me keep track of where I am in the problem. So I need two angles, and I'm out of given information. I need to prove that those two triangles are congruent. Okay, is there anything you guys see? There's not, I mean, we have that one hash mark. We already wrote that. I mean, what else is there? Do you guys see anything? Well, do you guys see these vertical angles? Those vertical angles means that those two angles are congruent to each other. So we can say that angle BCA is congruent to angle DCE because of the vertical angles theorem. You remember I told you that one was going to come back, and you're going to use it a lot in this section. Well, really just this whole like rest of the chapter, chapter 4. A lot of vertical angles. Okay, so that's an angle, right? So now we have all three sides and we have two angles, but we need one more angle. I wonder how on earth we're ever going to figure this out. We have two sets of corresponding angles. How are we ever going to get this third angle to be congruent to each other? If you're thinking in your head, angle B is congruent to angle E because of the third angles theorem, you would be correct. So we know that these three, this B and E are congruent to each other because of the third angles theorem. If we have two sets of angles that are congruent, that third angle in the triangle must be congruent to each other. Therefore, now we have three sets of corresponding sides and three sets of corresponding angles. So now we know that it is time to say that triangle ABC is congruent to triangle DEC because of the definition of congruent triangles, which just says, hey, if you have all three angles that are the same and all three corresponding sides that are the same, then those triangles must be the same because of the definition of congruent triangles. All right, that is it for example 3. We'll see in a little bit for example 4.